Hi there guys, I hope you're doing well. This is your friend and tutor Manas. To begin this session, let me ask you a very important question. Have you ever thought how engineering drawings are prepared? What exactly is the concept, the theory behind preparing these drawings? Guys, today I'm going to be explaining you how this entire process of preparing a drawing is carried out. So stay tuned as you're going to learn what exactly projection means, followed by the basics of orthographic projection, principal planes, quadrants and type of views, how drawings are made assuming the object to be in first and third quadrants, differences between first angle and third angle projection, symbols for these projection systems, and why it is not advisable to make drawings assuming the object to be in second and fourth quadrants. So here we go. Well, projection has two meanings. One is that projection in itself is an image, while the other meaning refers to the process or activity of obtaining an image. Now let me demonstrate how all of it works. So we have an object, a light source and a screen on which we would be getting an image. Alright, so when you switch on the torch, light rays are gonna emerge in all directions. Let me show you how that happens. Let us switch on this torch. These are the light rays. Let us do this quickly for this portion also, for this portion. Alright, that's it. This portion as well. This edge over here looks like this edge on the screen, some kind of a magnified form, and finally we have this edge. Okay, so it appears something like this. So this front portion is obstructing the light rays from going ahead over to this side. Okay, so this portion would appear something like this in some sort of a magnified way. Okay, and this is what you call the image, and these are what you call projectors or rays of sight. And guys, this is a very general way to understand projection. Okay, now let's take a look at orthographic projection. Now this orthographic projection comes under the category of parallel projection. Now when you speak of parallel projection, this is where the rays of sight or projectors or light rays are absolutely parallel to each other. So let's understand this with the help of a simple demonstration. So we have an object, so we have a screen. This screen in fact is technically known as plane of projection, and we have a direction of view in the form of this arrow. So we are going to view this object from here. Okay, the next thing to do is to extend projectors from the contour of the object until it meets this plane. Okay, something like this will happen. So these are the contours from the outline of the object. So this is the outline, and let's have this. Let's get this going. Okay, and from this side also. So this edge would look something like this, and finally this edge. Okay, so what we have basically done is we have extended parallel lines from the contour of the object to meet a plane, so that when all these points are joined in proper sequence, we get a view, and this is what you call a view or an image, or technically speaking it is called as projection. And these rays of sight, these are absolutely parallel to each other, parallel projectors you can say, and hence this orthographic projection in itself comes under the category of parallel projection. So that's how you project something onto a screen. And when these projectors are absolutely parallel to each other, you would say that parallel projection has taken place. And one more thing that I would like to show you is this. Let me show you this. Let us say I'm talking about this projector. Okay, it is absolutely parallel to the remaining projectors, but the most important thing is when it strikes this plane, it strikes at an angle of 90 degree. Finally I've been able to make a 90-degree angle, something like this. Okay, something like this. It's very difficult to draw something with the help of a mouse. Anyway, so guys, there are two conditions which are extremely important for any sort of projection to be called as orthographic in nature. Number one is all the projectors which will be extended to meet a plane are to be made parallel to each other. And secondly, the most important thing is that when these projectors meet the plane of projection, okay, meet this plane of projection, okay, they should make a 90-degree angle with the plane of projection. That's it. If these two conditions are satisfied, you can call that projection as orthographic, and then only you can have the true shape and size of the object, any object for that matter. So this was all about orthographic projection. Moving forward, in this particular section we'll learn about principal planes of projections. But before that, let us revisit what we've learned in school. This quadrant system has two perpendicular axes, namely x and y. This arrangement is divided into four quadrants: first, second, third and fourth. You know this very well. So you can say that this system can plot any two-dimensional object. But when you speak of a three-dimensional object, we need a three-dimensional coordinate system. So let us see how that can be done. So we have a vertical plane and we have a horizontal plane. Now these two planes are absolutely perpendicular to each other. Let me show you. and this plane over here is the horizontal plane. Fine. This arrow represents the direction of view. So whenever you want to look at the object from the front, you're gonna have to look at it from over here, and if you want to look at the object from the top, that's from here. Now this particular quadrant is what you call the first quadrant, and if I say that there is an object in the first quadrant, what basically I mean to say is that the object is above HP and it is in front of the BP. Similarly, this over here, behind this vertical plane and above this horizontal plane, we have second quadrant. Below this horizontal plane and behind this vertical plane, again we have the third quadrant, and over here we're gonna have the fourth quadrant, that is below HP and in front of VP. Now guys, let us see what views mean. Okay, so if you try to look at an object over from here, you're gonna have a view over here. So this is gonna be basically the plane on which you would be getting the front view. All right, and similarly, when you look at any object from the top, you're gonna have a top view, but that particular top view is gonna be seen here in this horizontal plane. Hence, for obtaining the front view, we have a vertical plane, and for obtaining the top view, we have a horizontal plane. Now guys, let's understand first angle projection, and for that let's have an object. So that's our object, and in order to have its views, we're gonna have reference planes or principal planes. So let's have the first principal plane in the form of vertical plane. Some people also refer this to as what do you call this, frontal plane. So let us write this down, frontal plane. This can also be referred to as a frontal plane. Let me write this. Moving ahead, for obtaining the top view, we're gonna have the horizontal plane. Alright, and for side view we have this profile plane. Fine, we're going to initially look at this object over from here, so that's going to be our direction of viewing for having the front view. And let's say that rays of sight or projectors are going to emerge from in this direction until they strike this plane, vertical plane. Okay, so these are the points at which it's going to be struck, and when all these points are joined in proper sequence, you're going to have a view. Something like this will happen, and you can clearly see that these rays of sight, I'm talking about these rays of sight or these projectors, apart from being parallel to one another, they are also making a certain angle with this vertical plane. Okay, this angle is absolutely 90 degrees, and this in fact is a condition for any projection to be called as orthographic in nature. Alright, so we have this front view, and let's see how this top view can be obtained, and for that we're going to look at this object from the top. Okay, and something like this will happen. Let me show you. Again, these are the points at which it has been struck. Alright, and you can clearly see when these points are joined in proper sequence, we have a view. Alright guys, something like this, and obviously these projectors are gonna be making 90-degree angles. You can see this angle is 90 degree, this angle is 90 degree. If you try to measure this angle, this will also work out as 90 degrees. Alright, now moving ahead, we're gonna make this side view, and for side view we need to look at this object from here towards from the left hand side. So this is left, you can write this, and this was about having the front view, so we had to look at this object from the front, and this was for top. Alright, now let's take a look at this object from the side this way, and hence we are having this. These are the projectors, parallel projectors, and this is the 90-degree angle. Alright, and we have a view, and in this case we are having a left hand side view. This over here represented top view, and this was all about front view. Alright, but the most important thing is this is not supposed to be drawn. Alright, this is just for explanation, and we have to convert this pictorial representation, this 3D representation, into some sort of a 2D representation. And for that to happen, there are a few things which you need to keep in mind. So there is something that I call this rotation protocol. Okay, let me write this down, rotation protocol. What is that rotation protocol? It says that horizontal plane has to be rotated by an angle of 90 degree in the clockwise sense, something like this, whereas this profile plane on which you're gonna have this side view, okay, it is also supposed to be rotated by an angle of 90 degrees, but the direction in which it has to be rotated is anti-clockwise in nature. Alright, now let's say we have this vertical plane. Okay, that's it. So that's the vertical plane. Now in order to make sure that this vertical plane, this horizontal plane and profile plane, all of them become coplanar, what we need to do is we need to rotate this horizontal plane in the clockwise sense. Something like this will happen, and also this profile plane in the anti-clockwise sense, again by an angle of 90 degree. And on doing so, you're gonna have this is going to be the vertical plane, below which automatically you will have this horizontal plane, and something like this will happen. this is gonna be your profile plane, okay, and it would look something like this on a plain sheet of paper. So this is going to be your profile plane, okay, and we're going to start off by making this front view initially. You can start off with any view. It is advisable to draw the front view or the top view initially, and then you can get going with the side view. And we're going to know this distance, what this distance is. We're going to make a point, and then we're going to go ahead and make this front view, something like this. So this over here represents the front view, and you can see this projector line over here, this line in the downward direction, and this angle initially was 90 degrees. But what we did is we rotated this horizontal plane in the clockwise sense by an angle of 90 degrees. So this line, which appears to be bent in this way, would appear eventually something like this as a straight line down below. So something like this would happen. This line from this point, we're going to go ahead in the downward direction, and we're going to reach here. This point corresponds to this point over here, and this point corresponds to this point over here. And when all these points are joined in proper sequence, we have a view. That is what you call a top view. Next thing to do is to have this side view, and for side view we're gonna do this. These projector lines are to be drawn. Something like this will happen. All right, the next thing to do is this distance I'm talking about, from this point to this point. Okay, now this particular line, this intersection line you see, is an intersection between profile plane and this horizontal plane. Okay, so this line appears to as if it is a part of this horizontal plane also, and it is a part of this profile plane also. Now this distance would appear over here, okay, over here, and this distance would also appear in this profile plane also, somewhere here. And these distances, this distance I'm talking about and this distance, appear as if both of them are equal. Now when both these distances are equal and this angle is equal to 90 degrees, you're gonna have a line over here, okay, at an angle of 45 degrees. So what you need to do is you need to draw a line over here at an angle of 45 degrees, and it's going to look something like this. That's it. All right, and you're going to go ahead in the upward direction. Finally, you have to draw projector lines from these points, something like this, and it's going to look something like this. And finally, these are the intersection points that you're going to get, okay, that you're going to get. And when all these points are joined in proper sequence, you have a view. And since you're looking at this object from the left hand side, you're going to have a left hand side view. So let us summarize all of these things, guys. So when you speak of first angle projection, okay, the thing that immediately should strike your mind is, number one, let me write this down with a different color. Number one. All right, so you have a plane of projection. Okay, so this vertical plane can be treated as a plane of projection. Okay, and in front of the plane of projection you're gonna have an object, right, and there is gonna be an observer. Okay, in all the three cases. So you have an observer over here, so this can be treated as an observer, then you have this object, then you have this plane of projection. Okay, so this is the protocol in first angle projection. Secondly, this plane of projection is non-transparent. When you speak of this line, this intersection line, this is usually referred to as a reference line. We call this the XY line. So we have an XY line over here, XY line, above which we have the vertical plane, below which we have the horizontal plane. So I'll write this over here. So we have an XY line above which we have the vertical plane, and below this XY line we have the horizontal plane. Now one more thing that's extremely important is we have the front view above the XY line, we have the top view below the XY line. So if this is the XY line, we have the front view above it and we have the top view below this. Fine. So this was basically a summary of first angle projection. Now I'm sure that you guys have understood what exactly first angle projection is all about. We are now going to go ahead and understand third angle projection. So let's see how it goes. So guys, let's have the object. So that's our object, and as far as third angle projection is concerned, the object is going to be behind the vertical plane, something like this. So this is the vertical plane, and it's going to appear as if it is below this horizontal plane. Okay, and when you look at this object from the side, you won't be able to look at the object. All right, so this profile plane in fact would come in between you and the object. Okay, let's say we want to look at this object from over here. So this is the front on portion, front. Alright, and we're going to look at this object from the top also for obtaining the top view, and we're also going to look at this object from the side. And to be very specific, I'm going to be looking at this object from the left hand side. So this is the left hand side, and we're going to be getting the left hand side view. Alright, my question to you is whether we're going to be able to see this object or not. Because here we have an observer, and in front of the observer we have the plane of projection, and behind this plane of projection we have this object. So what happens is, between the observer and the object, this plane of projection comes in between. So first thing that you need to make sure is that this plane of projection, let me write this, plane of projection has to be made transparent. This is the first condition when you speak of a third angle projection system. Okay, even when you look at this object from the top, you have this observer over here, let me write OBS, and below the observer you have the horizontal plane, and below this horizontal plane we have the object. So you won't be able to visualize the object. Alright, so in order to visualize the object properly, you're going to have to make this horizontal plane transparent. Hence, the most important thing when you speak of third angle projection is that planes of projections are to be made transparent. Now let's go ahead and have the front view, top view and side view. So initially we're going to be looking at this object from the front, and let's draw the projector lines towards this vertical plane in the backward direction, something like this. And these are the intersection points with the vertical plane, and obviously all these projector lines are going to strike this plane, okay, and we're going to be making 90-degree angles. Obviously that's why this is an orthographic projection. Apart from being parallel to each other, also strike the plane at 90-degree angle. So this was all about front view. Fine. Now let's have the top view. Okay, so we're going to be looking at this object from the top, and these so-called projectors are going to be extended towards this horizontal plane, and something like this will happen. These are the intersection points. Alright, let's join all these intersection points so that we can have a view. This is in fact a top view. And finally, let's have the side view, and for that let's have the projectors, something like this. Alright, and now these are the intersection points. Let's join all of these intersection points so that we can have a view, and this over is left hand side view. But what am I supposed to do? I have to make a two-dimensional representation, and for that I'm going to be using this rotation policy which I had explained you earlier. Okay, so horizontal plane has to be rotated by an angle of 90 degrees in the clockwise sense. At the same time, this profile plane is going to be rotated in the anti-clockwise sense, again at an angle of 90 degree anti-clockwise, something like this. Alright, and when you do so, this will happen. Watch this carefully. That's the vertical plane. Okay, so when you rotate this horizontal plane, it would appear as if it's here. Let me show you. So horizontal plane would appear over here. So this is going to be a horizontal plane, and that's the profile plane. Okay, something like this. So this is the profile plane. Okay, over here we will be getting the left hand side view. Here we will be getting the front view, and here we're going to be getting the top view. Alright, now let's go ahead and make this front view initially. Okay, so we have this portion from this point to this point. Okay, so this distance I'm talking about, this distance, and then once you have this distance, you can go ahead and make this front view. Alright, so this is the front view FV. Now we're gonna have to travel by this much amount from this point over here to this point, and then once you do so, you're gonna have this point, and you can now go ahead, this point I'm talking about, this point, you can have the front view. And finally let's have the side view. Okay, and you're gonna have to rotate this by an angle of 45 degree. I explained you the reason why. Alright, and then this intersection point gives you the final left hand side view. Alright, again let us summarize how all of this works. Summary third angle. Alright, so the first important point is, let me change this pen color. The most important point that I have to tell you is plane of projection are to be made transparent. Okay, the next important thing is, when you rotated this, okay, what happened was, if you have an XY line, this is the XY line I'm talking about, the intersection of horizontal as well as vertical plane. So this is the X Y line. Now what happened is, horizontal plane came above XY line and vertical plane was below. Second thing is, when you speak of the views, we have this top view above XY line. Okay, this is also a difference in fact, and this front view was below the XY line. Alright, so these are the two important points which come out as far as third angle projection is concerned. So guys, let us now go ahead and summarize the differences in fact between first and third angle projection. So let's go ahead. So the first important point is, when When you speak of first angle projection, so let me write this down. This is first angle, and this over here is third angle. So when you speak of first angle projection, the object is assumed above HP and in front of VP, and when you speak of projection done in third angle, you have the object below HP and behind VP. Okay, moving ahead, the plane of projection, when you speak of first angle projection, is absolutely not non-transparent. But when you speak of third angle projection, you have the observer, then you have the plane of projection, and behind this plane of projection you're going to have the object. So in order to visualize this object properly, you have to make this plane of projection transparent. That's why it is being made transparent. Moving ahead, VP is above XY line obviously, and HP below XY line. And when you speak of third angle projection, HP is above XY line and VP is below XY line. Fine. Moving ahead, we have the front view. Obviously, if VP is above XY line, that means the front view is going to be above, and here the top view is above XY line. Okay, moving ahead, we have this one more important point. Now, first angle projection is basically used in India, Russia, and some more European countries, whereas this is widely used in the United States of America. Third angle projection I'm talking about, that is assuming the object below HP and behind the vertical plane. Now let's move ahead and let's have the symbol. So this basically is the symbol for making sure that this every drawing prepared on a drawing sheet is made in first angle, that is assuming the object above HP and in front of VP. And if you see this symbol in any drawings in the bottom right portion, you will assume that the object was made, or the projection of object was made assuming that it was below the HP and behind the VP. Alright, so that was all about the differences between first and third angle projection system. Alright guys, now let's move ahead and let's see what else is in store for us. Now guys, we're gonna go ahead and see what the symbols are for first angle as well as third angle projection. Just try to watch this. This is what you call the frustum of a cone, and we have kept the frustum of this cone in such a way. This is the vertical plane. Over here we have the profile plane. So we're going to look at this object from here, that is from the front. This is going to be for the front view, and also from over here, that is for the side view. So this is first angle projection, and as I've already told you, profile plane has to be rotated by an angle of 90 degree anti-clockwise, and when you do so, you're going to have this. So this is going to be the front view, this is going to be the front view, and this is going to be the what you call left hand side, and this is finally what you see. This is the front view and this is the left hand side view of a frustum of a cone. Alright, so that's the Indian system, alright, or the Russian system. And now let's go ahead and see what this third angle projection is all about. So we're gonna make sure that this object lies behind this vertical plane, okay, fine. So when you try to look at this object from here, you won't be able to see the object. In order to visualize the object properly, what you need to do is you need to make this vertical plane transparent. That is in fact a condition, and you have an image over here. So this is the front view, and this over here is the left hand side view. And when you try to rotate this profile plane in the anti-clockwise sense, something like this, by an angle of 90 degrees ACW, you're gonna have these two planes coplanar, okay, in the same plane. And finally, when you draw this, it's going to look something like this. This is what you call the third angle projection system. And this is the symbol for first angle projection system. So guys, that was all about the symbols pertaining to different sort of projection systems. Now let me show you how these symbols can be drawn very technically. So this is the idea. Now guys, you can note this down, okay. Phi, phi, let me show you what phi is. Phi represents, or phi is basically a representation for diameter. So when you have to represent a diameter, you can put a phi over here, okay, initially, and then you can write this value. Let's say if we have a circle over here and whose diameter has to be represented, so you can just write over here, let's say the diameter is 40, so you can write this as 40. All right, okay. And similarly, if this is 40, this would work out as 1 by 4 times of 40, this distance, and this is obviously going to be 40, and that's it. This is how a symbol can be made in the bottom right portion of a drawing sheet. So guys, that was all about how this symbol can be made on a drawing sheet. Now we're gonna go ahead and discuss the final topic, very important topic in fact, as to why projection is not carried out in second and fourth quadrant. There is a very specific reason, there is a very genuine reason why this does not happen. So why does projection does not happen in second quadrant? So let's have the second quadrant. Okay, so this is the second quadrant, and we have the rotation protocol. Rotation protocol says that horizontal plane has to be rotated in the clockwise sense by an angle of 90 degree, and when you do so, this way, by an angle of 90 degree in the clockwise sense, you will see that both of them, HP as well as VP, they overlap. Okay, so I've written VP over here, HP over here. So let's say I have made a top view of an object, something like this. So this is representing the top view of an object, and this over here is representing the front view of an object. Now, if these two planes are going to overlap each other, these two views also are going to overlap with each other. Something like this will happen. Alright, and it would become a masala, and you won't be able to work out that which portion of this particular thing, which portion of this thing is the front view and which portion is the top view. And hence, in order to avoid this confusion, projection in second quadrant is absolutely not recommended. Okay, that's why it is not recommended. Okay, now let's see why projection is not recommended in fourth quadrant. So let's have the fourth quadrant. That means the object is below HP and in front of VP. So again, we are going to use this rotation protocol, and we're going to rotate this horizontal plane by an angle of 90 degrees in the clockwise sense. Okay, when you do so, what happens? This happens. Let me show you. Vertical plane, this vertical plane over here, and this horizontal plane, both of them appear as if they are below this XY line, or they overlap with each other. So what happens? If you're having a front view over here, let's say this is the front view and this over here is the top view, both of them are going to overlap with each other below this XY line, and it's going to get very difficult for you guys to understand which portion represents the front view, which portion represents the top view. And hence, in order to avoid this confusion, projection is absolutely not recommended in fourth quadrant. That's why first and third angle projection systems are so much popular. In India and most of the European countries, first angle projection is followed, whereas third angle projection system is followed in the United States. So guys, that was all from my side. If you have any doubts or queries, do write them down in the comment section below. I'll be very happy to answer them. And if you believe that this video tutorial has added value to your knowledge of engineering drawing, then do recommend this channel to your friends and classmates so that all of you can learn engineering drawing in the best possible way. This is Manas Patnaik signing off. Take care, have a great day, and keep drawing. Stay blessed.